called Emoji Photo, and it uses a couple different microservices, but it's pretty simple. There's a web service that handles the front end, and then there's two gRPC backend services called voting and emoji. And if I actually, I'm in my cluster right now, and if I actually take a look at my deployments in that namespace, I can actually see them here, and they're ready to go, which is great. So this right here is what I actually have deployed to my remote shared development cluster, right? So it's kind of a fun application. There's these emojis that I can vote on. There's this leaderboard that shows the voting results of how different emojis compare to others. And as a developer, I want to be able to work on one service, let's say the web service, without having to actually deploy and manage the other services, the voting and emoji services that are sitting behind it. So let's say that I've been tasked with making some changes to my front end web service. So what I'll do is I'm going to go to my IDE. I just use VS Code, and I'll go over to my web service and I'm going to make a change. So I'm just going to change the title from emoji vote to I love debugging. Just a quick change. All right. And then if I actually want to see my changes, right, I can launch my debugger. And we can see now that my service is running locally and it's running on port 8080. So if I actually visit my localhost, you can see some of the changes that we've made, right? You can see the title change up here. I love debugging now. The background's a different color. The text is different than what I've deployed in my cluster, right? It's pretty different from this. But as you can see, we don't see any of the emoji definitions or any of the voting behavior. And that's because we only have the web service running locally. So it isn't connected to the cluster and the other dependent Kubernetes services. So right now, I don't really have a way to do full end-to-end testing and know how my application will actually look inside the cluster. So how do I actually go about solving this problem and resolving these dependencies? So there's a couple different ways that we could actually solve this problem. One way is that I could also run my dependent services, the voting and emoji service locally to meet these dependencies. And that might work right now, but as my application gets more complex and as I have more intricate dependencies, this can grow to be a little bit cumbersome, and I don't want my computer to start melting as I'm running everything locally, right? And then alternatively, I could go through the work of actually deploying these changes I've made to my shared development cluster. But then I'd have to go through a whole CI/CD process to build and deploy my application to a target environment to verify that the code is working correctly. And the issue with this is that it's pretty time consuming, and I might do all that work and then find out, maybe the changes I made don't work or they're just not what I want, and then I have to go through that entire process again. So the whole idea around the Ambassador Labs product telepresence is to simplify this inner dev loop, right? So as you start to move towards a GitOps and more automated deployment workflow, this will result in some difficulty in terms of managing and deploying your microservices. So telepresence specifically is used to simplify some of the Kubernetes networking principles and deployment pathways to make it easier for you to interact with Kubernetes clusters from your local machine. So that was a lot, but broadly, you can think of telepresence as a bridge between your local deployment development environment and your remote Kubernetes cluster that you're connecting to, so that you and your developers can quickly write, test, and iterate on your code changes. All right, so let's see what that actually looks like in action, right? So first I'm going to spin up telepresence and connect to my cluster. So all I have to do is make sure I'm in the right context, and then I just run telepresence connect. Great. So with this telepresence connect, we're able to run as essentially a networking extension to be able to connect a process running on a local machine to a remote environment and resolve dependencies. So now that I'm connected, if I actually refresh my local host, we can see that the emojis now populate, which is great. So without having deployed anything to my cluster over here, we can see what end-to-end traffic may look like in telepresence. And resolving, or we are able to resolve these dependencies and iterate and develop from here. And so by resolving these dependencies, telepresence is already a great tool, but now we want to see actually what this end-to-end traffic may look like with telepresence, right? So this is where creating telepresence intercepts come into play. And I'm going to pull up a little graphic because I feel like it'll be helpful with explaining them. So this is a little visual of how intercepts work in telepresence, and this is sort of one of the key concepts behind telepresence. So we can see here that if there is no intercept, and this is my shared development cluster, we have traffic hit our API gateway and then get routed to our microservices. But with telepresence, we can actually intercept traffic that would go to a service in the cluster and reroute it to the version running on our local machine. So in the open source version of telepresence, you can intercept traffic that would go to a service in the cluster, and it will redirect all that traffic to your local machine. So you would just have to let other developers you're working with know that you're currently intercepting traffic to this service. So we usually recommend this route more if you're more of a solo developer, or maybe you have developers working at much different hours. So it doesn't really matter if they're stepping on each other's toes at all. But then with the proprietary version of telepresence, you can actually make use of a feature we have called personal intercepts, where you can create multiple intercepts on the same service and have multiple developers working on the same or different services within that shared cluster and not affect each other. And how this works is telepresence uses a header to dictate which traffic will go to each developer's machine. So essentially, when you create an intercept, if you specify the particular header that you want to associate with that intercept, you can assign different headers to two particular intercepts and two particular developers, and have multiple developers working in the same environment on the same services without stepping on each other's toes. So that was a lot of information, but let's see what that looks like in practice. So first, I want to take a look at my emoji Vodo namespace to see what services are actually ready to be intercepted. So I can run telepresence list and then specify the emoji Vodo namespace. And we can see here that actually all my services are ready to be intercepted, but since I'm developing on the web service in particular, I'm going to be intercepting that. So in order to intercept the web service, I run telepresence intercept, and then I specify the service. So web, I specify the port, which is 8080, and then I specify the namespace, which is emoji Vodo. And then if I run that, it will create this intercept for me. I'll pull it out a little so you can see it better. There you go. So now that this intercept is created, traffic that goes to the service will be rerouted to the local version running on my machine. And my local service can make calls to other services in the cluster as if it were in the cluster too. So it really simplifies a lot for Kubernetes development. And as you can see here, this intercept was created and it gave us a couple of different pieces. So let's break those down, right? So the first and the most important piece is this intercept ID header. So this says that any request that comes in and is intended for my web service front-end application that I'm intercepting, if it contains this header, instead reroute it to my local machine instead of using the version in the remote cluster. Right, so that's the key piece that makes this personal intercept work. And then the other piece that's very useful is the preview URL functionality. So that's this right here. So basically what the preview URL does is it generates a new DNS name where if you send a request to the preview URL, it will automatically attach this header and send it to the ingress. So you can see that if we actually go to this preview URL, we can see now the local version I have running and the changes that I made. And the preview URL is a great tool because you can really just easily share it with your teammates who can then test out your local service remotely. And we can see that at this preview URL, all the appropriate changes that I made are here. So the local version on my machine is appearing. And we're able to interact with these emojis and the dependent services launched in our shared development cluster. And the other key thing I want to note, in case this is a concern, is that we're also still able to interact with our debugger over here. And anything we have running locally to resolve these dependencies, while at the same time, if people on your team want to interact with your remote cluster, so this is it over here, it still functions properly and it's still the deployed version of the web service. So it doesn't actually affect any other services that are deployed to the cluster. And I'm only selectively deciding that traffic that goes to this particular DNS name over here should utilize my local machine instead of the microservices I have running in the cluster. Cool. So that's kind of a broad overview of telepresence and what it seeks to solve. It's really focusing on simplifying and really speeding up that inner dev loop process when you're trying to develop in Kubernetes. So if you find that that's a problem for you, or if you're wasting time with with actually deploying your application to see your code changes, or if your computer's melting because you're running everything locally, then I definitely recommend trying out telepresence. It's free to use until you'd like to use personal intercept. So yeah. Okay. I know that was a lot of information. So if anyone has any questions in particular about telepresence, definitely feel free to ask. Or about Ambassador in general too. I'm going to turn my camera on. I'm the only one with it on.
Does anybody have a question? Any questions?
Yeah, or if anyone wants to share like how you may be developing currently, that would be cool too. Yeah, and we also have a tool called Ambassador Edge Dock, which is just our API gateway, and that's also free to use until you'd like to use our proprietary features, which are authentication using OAuth, JWTs, or maybe an external authentication service that you'd like to plug in, or and also we offer rate limiting as well through that. So, but yeah, it's all free to try out. And if you run into any problems, we also have an open source Slack channel where you can ask questions and we try to answer them. And I guess to answer the question from earlier, it's kind of like a CI/CD tool, but it's a little bit more simple because you're actually, it's more like a VPN almost, because you're actually able to, you don't have to go through the whole process of actually deploying. Instead, you can just instantaneously see your changes. And that's just through the architecture of telepresence. And I can actually link to how that works. So it's kind of interesting. Let's see. And yeah, I'll send a Slack invite to you. And Pradeep and Akash.